In this lesson, we are going to use the determinant now to find the inverse of a 2 by 2 matrix. So again, as you know, we have been using augmented matrix method to be able to find the inverse of a 2 by 2 and 3 by 3 matrix. Here is the shorthand way of finding the determinant, of using the determinant to find the inverse of a 2 by 2 matrix so that we don't have to use the augmented matrix method. So in the previous lesson, I showed you how to find the determinant of a square by square matrix, whether it was 2 by 2 and 3 by 3. But here we are going to just focus to finding the inverse of 2 by 2 matrices. All right. So here is a given matrix 2 by 2, A, B, C, D elements, and the formula to find the inverse of said matrix is as follows. So it will always be 1 over the determinant of whatever A is. So hopefully you are recognizing the fact that AD minus BC actually is just the determinant of matrix A. AD is the multiplication of this diagonal minus BC is the multiplication of this diagonal. So first you would find the determinant, and whatever that value is, that will be the denominator of this fraction. Okay, now you are going to take that value, 1 over said value, and you are going to distribute that number to every single element in this matrix. But what I want you to notice is that the elements did change. Okay, so notice here this diagonal, this AD diagonal, changed in order. All right, it became DA. So A and D, whatever those two numbers are, you are going to interchange them and they become D and A. Okay? Now, when it comes to this diagonal, notice that they are not interchanged. Their signs are flipped. So whatever B is, you would flip it to the opposite. So if B was 3, this will become negative 3. Same thing with C. Whatever C is, you will flip it. So if C upstairs was a negative 4, downstairs it would become a positive 4. All right? So let us practice doing 2 problems and see if we can come up with some answers. Okay, so we are going to start with problem number 1. The matrix was 3, 2, 2, negative 1. Let's call it matrix A, okay? So matrix A, 3, 2, 2, and negative 1, okay? Let's put brackets because this is our matrix. So first of all, what we're going to do is go find the determinant of A. So the determinant A says that we take 3, multiply it by negative 1, and subtract it from the multiplication of the other diagonal. So we get negative 3 minus 4, which is negative 7. Okay, that's my determinant A. So to find A inverse, the formula says I'm going to put 1 over the value of my determinant, so negative 1/7, and I'm going to distribute to the elements of the newly formed matrix. So the 3 and the negative 1 are interchanged. So negative 1 goes here, 3 goes in the bottom corner, and then the elements in this diagonal are going to be switched in sign. Positive 2 becomes negative 2, becomes negative 2. That's my new matrix. And now I'm going to take this scale factor and I am going to distribute to every single one of those elements. So the answer will become, I'm going to raise this up a little bit, positive 1/7, positive 2/7, positive 2/7, and negative 3/7. And I will close off, and you are done. So yes, so much easier than doing augmented matrix. Okay, so that's number 1 on that page that you're working alongside with me. Let's go do number 6, and then the remaining problems you will do on your own. So number 6 gives us another matrix. We are going to call this matrix B. Okay, so it is, oh, okay, wait a minute. Here they're doing something else. Let me see. Let me read this problem. Okay, so now that I've read the problem, let's write it out, and then I will explain the intent of this problem. So we have 2, 4, 1, and 3, and you are multiplying it by B, some matrix B, and it's going to equal 1, 1, 2, 4. So this is kind of a solving of equations type problem. So right now what's given is we have a matrix times some matrix that we're calling B, and when you multiply those matrices by doing row times column, etc., you will end up with this matrix right here on the right hand side of the equal sign. Okay, so we're solving for B. Now the thing is, in matrix land, for lack of better words, you can't just say, oh, okay, well, I am going to divide both sides by 2, 4, 1, 3. Sorry. I'm going to divide both sides by this matrix, you know, and so this cancels, and now I can solve. I keep putting that line. You can't do that in wonderful matrix land, okay? So what is it that we need to do? Well, we need to get rid of this, right, to get B by itself. So in matrix land, what you do is you need to multiply that by its inverse, because remember, when you multiply a matrix by its inverse, you get the identity matrix, which in essence is a 1, right? So that's what your goal is. You're trying to get rid of this right here. So I need to find the inverse. So let's pretend that this here is matrix A. Okay? So what I need to do is I need to take what am I saying? This matrix right here. So 2, 4, 1, 3, that is right next to the B matrix. I need to multiply it, and I need to scoot my page over, by, let me write backwards here. I need to multiply it by its matrix inverse, all right? I need to multiply it by its matrix inverse, because if I multiply those two, I will get the identity I. But if I do that, I must do it on the other side as well. So notice how I put the inverse matrix in front of 2, 4, 1, 3 of matrix A. So I'm going to do it over here as well, because order matters, right? So 2, 4, 1, 3, the inverse, and then bring down this 1, 1, 2, 4. Okay, so all I did, just to highlight here so you don't see the difference, if I multiply this side by an inverse, I must multiply this side by an inverse. That's all I'm doing. Okay, so I inserted the inverse on both sides. Why? Because I wanted the inverse to cancel with the given A matrix so that B can come down by itself, and now I have to multiply the inverse of this matrix, which I don't know what it is, okay, times this matrix. So what we need to go do is go find what this is. Find my A inverse, okay? Because remember, that's what I called it. I called this A, so I'm looking for A inverse. So let's go find A inverse. So first thing I need to do is find the determinant. So the determinant of A is going to be 2 times 3 minus 1 times 4, which is going to be 6 minus 4, which is 2. Okay? So determinant A is 2. And now my A inverse, which is what I'm looking for, is going to be 1 over 2. And let's go do the switcheroo. Whoops, is that the? Yeah. The switcheroo of that. So 3 goes up here, 2 goes down here, and then I need to switch the signs. So positive 1 becomes negative 1, and positive 4 becomes negative 4. So when I distribute here, the half to everything, I'm going to get 3 halves, negative 1 half, negative 4 halves, which is negative 2, and 2 over 2, which is 1. So that's my A inverse. Okay? So that is what I was looking for there. All right? A inverse is this matrix. So now to find B, this is a long problem. I take the answer that I got and substitute it for that A inverse matrix. So that is 3 over 2, negative 2, negative 1 half, and 1. And I have to multiply it by, what was the other matrix? 1, 1, 2, 4. 1, 1, 2, 4. So let's multiply row by column, row by column. So this is a 2 by 2, and this is a 2 by 2. So I am allowed to multiply because that and that match. So my answer is going to be a 2 by 2. So let me actually not put this here. Let's, just in case I need some space. So we do row by column. So 3 halves. So row, let me circle this, row by column. So 3 halves times 1 minus a half times 1. Then I do it again for the other one. I'm going to multiply it with this one. 3 halves times 2 minus a half times 4. Then we'll do it again. This row by this column. So negative 2 times 1 plus 1 times 1. And now I do that row by this column. Repeat it. Negative 2 times 2 plus 1 times 4. And so notice how this problem pretty much puts everything together. So when you do all the arithmetic, you get 1, negative 1, 1, and 0. So your challenge is to do 7 and 8 and practice with those. Okay? Thanks for watching.